Welcome back to Math Savvy. We're about to learn about the quotient rule. So you're going to use the quotient rule when you have a function dividing another function. So if you have something with a bunch of x's in it divided by something with another bunch of x's in it, you're going to have to use the quotient rule if you want to take that function's derivative. So you need to memorize the quotient rule, which looks like this. So this top function is going to be called f. You're going to take that derivative and then multiply it by the function that's in the denominator. Then you're going to subtract, kind of like the opposite. You're going to subtract the top function left alone, multiplied by the derivative of the bottom function. And then you're going to divide it all by the bottom function except squared. You might hear a lot, low d high minus high d low all over low squared. And that kind of sounds like gibberish, but it says, okay, low d high, low, then the derivative, that's what d is. So low d high, so low times the derivative of the higher one, minus high d low, so minus high, this one, then times the d low, so d's...
Got it!
Times the derivative of the bottom one all over low squared, the bottom one squared. So let's try an example, shall we? So this is our first example. We can tell that we're going to have to use the quotient rule because we have something with x's being divided by another thing with x's in it. So we just have to follow this formula up here. So let's start by taking the derivative of the top function. The derivative of this is just going to be 6x. Then we have to multiply it by the function in the denominator, so times 4x cubed. Then we have this minus here, so you plug that in. F of x left alone is just 3x squared plus 2. Then times the derivative of the bottom one, which is 12x squared. And then we have to divide it all by the denominator, but then square the denominator. So this would be your final answer for the derivative of this function. Next example, we know that we are going to need to use the quotient rule here because we have something with x's, the sine x, being divided by something that also has x's in it. So we know we're going to have to use a quotient rule. So it's really just plug and chug from here. Yeah! The derivative of the top function is just going to be cosine times the bottom function left alone, that's 3x squared. Then minus f of x, so the top function, sine x, times the derivative of the function in the denominator, which is just 6x. Then it's going to be all over the denominator's function squared. So if we cube 3x squared, it's going to turn into 9x to the fourth. So this is going to be the derivative of this function here. Let's take this function's derivative. Again, quotient rule because we have a bunch of things with x's being divided by another thing with an x in it. So plug and chug. Yeah! Let's start with this f prime of x. This is f of x, so its derivative is going to be 12x squared plus 40x cubed. Then we multiply it by g of x, cosine 3x, minus f of x times the derivative of g of x. But notice g of x, we're going to have to use the chain rule here because it's not cosine of just x, it's cosine of 3x. So remember to use the chain rule. We take the derivative of the outside function, which is negative sine, and then leave the 3x in the middle the same. And then we have to multiply it by the derivative of the inside function. The derivative of 3x is just 3. So it's going to be times negative 3 sine of 3x. And then all over the denominator squared. So you can simplify this out. If you switch these around, this negative 3 and this negative sign is going to cancel out to a plus. Hit me up for tutoring at math-savvy.com. I hope you have the best day ever. Bye.